Hello students, you are welcome once again to Eko Learners Support for WAEC and NECO candidates. And today I remain myself, my humble self, Kamaldeen Abiona. And we'll be looking at another aspect of mathematics today, an important aspect, and that is probability.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
I welcome you to the world of probability. This is a fascinating aspect of mathematics, and major thing is that we want to understand, it will help us to understand the likelihood of events happening. We also want to know how we can make informed decisions with probability. So those are the learning objectives that we want to look at today. So what do we mean by probability? Probability is just the measurement of the likelihood of occurrence of an event. All right. So there is need for us to also decide to define some terms in probability. What are the terms that we need? Number one is experiment. We'll be mentioning experiment, where I don't feel it is the experiment in chemistry or physics, but this is just a statistical experiment or mathematical experiment. And what do we mean by an experiment? An experiment is any process with uncertain outcome. We are not sure of the outcomes. So this could be flipping a coin, rolling a die, drawing a card. You see, we are not sure when you toss a coin, we are not sure of what will actually appear. Is it a tail? Is it a head? The same thing to rolling a die. We are not sure. Is it 2 that will appear or 5 or so? So we are not sure. And the same thing as drawing a card. So that is why we say experiment is a process with uncertain outcomes. We are not sure of what will appear. What do you mean by outcome? I've mentioned outcome in that definition. An outcome is a single result of an experiment. So any result at all is an outcome. When I throw a die up and 2 appear, that is an outcome of that experiment. So we also know what we have as a sample space. What do we mean by sample space? Sample space is the set of all possible outcome of an experiment. When I throw a die up, what are the possible outcomes that I'm likely to get? You know, it could be 1, it could be 2, it could be 3, it could be 4, it could be 5 or 6. You can't tell me that 7 will appear. So 7 is not part of the outcome of a toss of a die. So in that case, we have 1, 2, 3, 4, 5, 6. We also have what we call events. Event. What do we mean by event? Event is what? It's a specific outcome of an experiment, or we say the favorable outcome, a specific outcome of an experiment. For example, rolling an even number. In rolling a die, what is the probability that an even number occur? What are those even numbers? So even number in that case is what we mean by an outcome, an event. So we also have, so based on what we have defined now, we should be able to tell in specific terms what we mean by probability. So probability deals with the relationship between events and their possible outcome. Events and their possible outcome. You remember that we talked about sample space, which is the total possible outcome. So it means from there we can say that probability can be said to be the relationship between the event and what? The sample space. Okay? Event and sample space. All right. So as a result, we can just simplify it or summarize it. That probability of an event, so we can summarize it, that probability of an event equals number of events over number of sample space. You remember in sets we have mentioned cardinality. So that is what I've used there. Probability of an event E equals number or cardinality of the event over the cardinality of the sample space. All right. So, and that is what we'll see here. We have some examples here: event, outcome, and the probability. So based on our definition, flipping a coin, when you flip a coin, is either we have a head or a tail. And that is 2 outcome. 2 total possible outcome is 2. So the sample space, number of sample space is 2. But we are asking of probability of what? Having a head. So what's the probability that the head occur? How many heads do we have? So the outcome or the event now is head. So how many heads? And that is just what? 1. So, and that is why we have 1/2 for that. Another one, rolling a die. Even numbers. Even number. So the E there, don't forget, is the favorable outcome. Favorable outcome of an experiment. So rolling a die. And we need even numbers. So what are the even numbers that we have in a die? Firstly, what are the results of rolling a die? What are the results? We have 1, 2, 3, 4, 5, 6. So the cardinality is what? The cardinality is 6. All right. The cardinality for that is 6. And even numbers. What are the even numbers there? Write them out. We have 2. We have 2. Okay. We have 4. We have 6. So what is the cardinality of that? That is 3. That's why we have 3/6. And in mathematics, we don't leave that because we can still simplify. We have what? 1/2. So the probability of having an even number is 1/2. Then we also have drawing a card. Drawing a card. So in this case, we know that in drawing a card, what is the total possible? And we have 52. 52. We have 52 cards in a pack, and we have ace of spades. So how many of that? You know, in cards we have spades, we have diamond, and each of them is what? 13, 13, 13. But in this case, how many hearts do we have in what? In the spade there that we have there is just 1. So they say hearts of a spade, it is just 1 out of the whole of what? The 52. Out of the whole of 52. Assuming it is probability of having a spade, then that is when you can say 13, because number of spades that we have is 13 out of what? 32. But the question being asked here, so you have to be very careful of the question. The question is the ace of spades, which is just 1 out of the whole of that 13 spades. So it is 1/52. 1/52. So that is the solution to that. So we can see, based on our definition, we have been able to solve problems that involve probability. All right. So let's go on. Then probability 2, based on the questions that we have solved, we can divide them into 2 areas, 2 aspects. The first one is what? Experimental probability. And when we have experimental probability, it's based on the observation, what you observe. You have observed that in the past, these are the things that always occur. So it is what is calculated by what? Dividing the number of times of an event or favorable outcome by the total number of the total occurrence. And that is what you mean by experimental probability. A very good example is, you can look at today. Okay, what is the probability that there will be rainfall based on the past, what has happened in the last 1 week? In the last 1 week, it could be that out of the 7 days, there was a rainfall for 3 days out of the 7 days. So in that case, that is the favorable outcome. The number of favorable outcome. Then how many days are we considering? We are considering 7 days. Out of the 7 days, we had rainfall in 3 days. So as a result, in that case, you say the probability is what? 3/7. So that is that. So you conduct trials, perform an experiment multiple times, such as flipping a coin. Then we keep track how many times each event occurs, and we calculate the probability. How do we do that? We divide the number of favorable outcomes by the total number of trials, which is also one of those things that I've mentioned now. So, okay, now take examples, more examples on that. You flip a coin 10 times and get 6 heads and 4 tails. The experimental probability of getting heads is what? 6/10, because it was repeated 10 times. And what favors us? Probability of getting heads. So how many heads do we have? 6 heads in the whole of the 10 times that the coin was flipped. So it means 6/10, which is 0.6. Another example, rolling a die. You roll a die 12 times and get 6. The experimental probability is what? Of rolling a 6. Is how many times 6 occurred out of the 12. That is 3 out of 12, 3/12, and that is 0.25. We can also have in a die, in a card. You draw a card from a deck of five times, from a deck 5 times, and get 2 hearts. The experimental probability of drawing hearts is 2/5, because you repeated it 5 times, and the one that favors what we need is what? Is hearts. So 2 hearts, that is what? 2/5. All right. So we have been able to understand what we mean by experimental probability, and this is now theoretical probability. So theoretical probability is based on the logical analysis of an experiment. It is calculated by dividing the number of favorable outcomes by the total number of possible outcomes in the sample space. And theoretical probability assumes that all outcomes are equally likely. And a very good example of that is flipping a coin. You already know what are those things. It's either head or tail, and they are equally likely. So the probability that we are having one head will still be the same thing as what? That of the tail. The same thing when you throw what? When you throw a die. So each of them, 1, 2, 3, 4, 5, 6, they are all equally likely. Likely to what? Occur. So examples, rolling a die. So the theoretical probability of rolling a 4 is 1/6, because there is one favorable outcome, that is rolling a 4, and 6 total possible outcomes. So that is why it is 1/6. Drawing a card. The theoretical probability of drawing a coin from a standard deck of 52 cards is what? 4/52. Why? Because there are 4 coins, and the total is what? 52 cards. So that is 4/52, which is 1/13. Another example, choosing a marble. If a bag contains 5 red marbles and 3 blue marbles, the theoretical probability of choosing a blue marble is 3/8. Why? Because there are 3 blue marbles out of 8 marbles. So I hope you understand that. So to deepen our knowledge or understanding of that probability, so let's look at these questions. Number 1, a bag contains 3 red balls, 2 blue balls, and 5 green balls. What is the theoretical probability of picking a red ball? Theoretical probability of picking a red ball. So let's look at that. So what is the total? We have 3 red, 2 blue, and then 5 green. So the total number of balls is what? 3 plus 2 plus 5. And that is 10. All right. So what's the probability of picking a red ball? Red. So how many red? It means it will be what? Probability of picking a red will be number of red over the total. So how many red do we have? 3 red. 3 red ball out of 10. That's 3 over 10, which is same to now 0.3. All right. So you flip a coin 20 times and get 12 heads. What is the probability, experimental probability of getting tails? You can see this is an experiment that we performed so many 20 times. So what's the probability of getting tails? 12 heads. Be careful here. 12 heads out of 20 times. So it means we have 8 tails. 8 occur. The tail occur 8 times. So probability of having a tail will be number of tail, which is 8, over the total number of times the experiment was repeated, and that is 8 over 20. And what will that give us? 4 here 2, 4 here 5. So that is 2 over 5 or 0.4. So, all right. Okay, let's move quickly. So this is also what some questions that we also need to look at. Not yet. Okay, let's look at it together. You roll a pair of dice. What's the probability of rolling a sum of 7? What is the probability of rolling doubles? You roll a pair of dice. What is the probability of rolling a sum of 7? And what is the probability of rolling doubles? So in this case, what do we mean by that? A sum of 7. All right, so this is quite different because a pair of dice. A pair of dice means 2 dice. So with that, we have something of this nature. Let's say this is the first die. 1, 2, 3, 4, 5, 6. Outcome of the first die. Outcome of the second die. 1, 2, 3, 4, 5, 6. All right. So we are looking for sum of 7. Here we can have 1, 1. The first one may be 1 and the second one is 1. But what we need here is the sum. So add them together. 1 plus 1 is 2. 1 plus 2 is 3. When 1 occur here and 3 occur here, the addition is 4. Like that, you fill in this particular table, 6, 7. This is 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. And this is what? This is 7, 8, 9, 10, 11, 12. The question is, what's the probability of rolling a sum of 7? Sum of 7. This is sum of 7. So how many sum of 7 do we have? 1, 2, 3, 4, 5, 6. That is 6. Out of what is the total? If you count this, the total outcome is 36. So we have over 36. So which is 1 over 6. And lastly, we have okay, yes, this. I will leave that. This as a, okay, so this is rolling of dice. Doubles. So what do we mean by doubles? You know what we will say double when you are playing Ludo? I will say you have double 6 or double 4. So doubles, it means 1, 1 to get double. 2, 2, another double. 3, 3, double. 4, 4, double. 5, 5, double. And 6, 6, double. So how many doubles? 1, 2, 3, 4, 5, 6. So also 6 out of 36. And that is 1 over 6. All right, so the last question there, a coin is tossed 30 times and it lands on heads 18 times. What is the experimental probability of getting tails? So head is 18 times. The remaining, which is 12, is for tail. And probability of tail will therefore be what? That is number of tail, which is 12 over 30. Okay, sorry, over 30. So this is 6 here is what? 2, and 6 here is 5. So we have 2 over 5 for that. So let's look at this practice question. All right. A bag contains 7 white marbles, 4 black marbles, and 3 red marbles. What's the probability of drawing a black marble? What's the probability of drawing a white marble too? Then a spinner has 6 equal sections labeled A, B, C, D, E, and F. What is the probability of spinning an A? And what's the probability of spinning a vowel? All right, so I give you just a minute to answer that quickly. Okay, thank you. I hope you got that. All right, so let's look at the questions together. A ball contains 7 white. Yes, 7 white. 7 white balls. Let's look at it. 7 white marbles, 4 black, and 3 red. Can we just add that together? 7 plus 4 plus 3. And that is 14. Okay, so what is the probability of drawing a black marble? Black marble. So from that, what do we see? You can see it. So how do we do that? What is the probability? Black marble. So where is black? This is black. Okay. So we have 4 black. So probability of picking a black marble is 4 out of the total, which is 14. Okay. So that is, you can now break that down. That is 2 over 7. So you can leave it like this or find the decimal form of that particular answer. All right. What is the probability of drawing a white marble? Do we have white there? Yes, this is white. This is white marble. So probability of drawing a white marble. How many white do we have? Probability of white will be equal to number of white, and that is 7 out of 14. So which is 1 over 2. All right. And the last question says a spinner has 6 equal sections. So see that these are the sections of the spinner. So a spinner, I think I've shown that in something of this nature. Okay. So 6 parts. What is the probability of spinning an A? What's the probability of having an A? Out of how many parts? 6 sections. And it is just 1 out of 6. So the probability of spinning an A is this. The next question, what is the probability of spinning a vowel? So where are the vowels here? We have this is a vowel. Which other one? This is another vowel. That is 2. So probability of having a vowel is 2 out of 6. And that is 1 over 3. So I hope you got those questions correctly. Wow, that's great. That's fantastic.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
So I will employ you to practice more, and if there is any question, comment, you can always make use of the link shown on the screen. Thank you very much, and we'll see you next time.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.